Spectral denoise is a general-purpose tool for getting rid of steady background noise in a recording. Voice denoise does the same thing, but is optimized for dealing with noise in vocal or dialogue recordings. You can think of the denoise process as a kind of noise gate, only this gate will remove noise that's present at the same time as the main signal, under the main signal, instead of only during pauses, like with a traditional dynamics-based gate. To do this, the denoise modules have to build a profile of the noise. That is, they have to get to know what's noise and what isn't, so they can successfully remove the noise while leaving the desired audio intact. Let's look at this in spectral denoise first. The noise profile can be learned automatically, or you can do it manually. Let's try it with this recording that has air conditioning noise in the background, a common problem, especially with project and home studio recordings. Here's an audio recording that was made in a room with an air conditioner running in the background. The sound of the air conditioner isn't too overpowering, but we're going to see if we can get rid of it anyway with the spectral denoise module. If we're successful, spectral denoise will be able to identify the AC sound and then remove it from under the vocal recording. If adaptive mode is on, then the module will learn as it processes, analyzing the audio for main signal and noise, and determining which is which. If you want to do it manually, you can turn off adaptive mode, make a selection, or even multiple selections, of just the background noise, and then hit Learn. The handy graph shows what's what: input level, in gray, output level, in white, and the residual noise floor after processing, in yellow. The two sliders to the right control this, just like the equivalent controls on a regular noise gate would. Threshold sets the level between noise floor and signal. Reduction sets the amount of attenuation of the noise. Here's an audio recording that was made in a room with an air conditioner running in the background. The sound of the air conditioner isn't too overpowering, but we're going to see if we can get rid of it anyway. Just as with a regular gate, a higher threshold will reduce more noise, but may catch some of the main signal as well, resulting in processing artifacts. Likewise, higher reduction settings will push the noise down further, but again may affect the main signal a bit if overdone. If I thought I could still hear a little of the AC noise under the voice, I might try more aggressive settings. Here's an audio recording that was made in a room with an air conditioner running in the background. The sound of the air conditioner isn't too overpowering, but we're going to see if we can get rid of it anyway. The quality slider can be brought into play for more difficult denoising situations. A is the basic, fast, low CPU algorithm, and is probably fine most of the time. B, C, and D increase the computational complexity and the resulting CPU overhead for situations where the noise is more prominent or the main signal is buried further in the background sound. Artifact control balances the processing between spectral processing and wideband gating. Lower values utilize the spectral processing more, but may allow little chirps or other spectral artifacts. Higher settings lean more toward wideband gating, but may cause the noise floor to pump a bit. If you hear either of these types of artifacts, adjusting this slider appropriately may help clean things up. Here's an audio recording that was made in a room with an air conditioner running in the background. The sound of the air conditioner isn't too overpowering, but we're going to see if we can get rid of it anyway. That's better. The AC noise is gone, and the voice sounds clean. If you still can't get a clean enough denoised signal, you can open the Advanced tab and dig a little deeper into the controls provided for fine-tuning the analysis and processing. You'll see a couple of controls that should be familiar from regular dynamics-based noise gates: knee and release. Naturally, knee smooths out the detection for noise signals near the threshold, possibly resulting in fewer artifacts, while release can be used to address issues like slight softening of transients. The other advanced controls affect the algorithm and the tonality of the residual noise floor itself. You can select more complex algorithms. Notice how the quality setting changes these. The FFT size can be altered. FFT stands for Fast Fourier Transform, the math used in spectral processing to isolate different elements of the complex signal. Audio is processed in very small time and frequency segments, and tweaking this control can impact how effective that process is. Note, if you do change this, you'll need to rerun the learn function, as the old noise profile will be invalidated by any changes here. Under Noise Floor, you have 4 controls that can subtly shape the sound of the processed audio, again reducing artifacts, especially subtle high-frequency loss. As you can see, the voice denoise module has pretty much the same controls and functions as the basic spectral denoise layout, except that its algorithm has been optimized to remove noise and background sound under a voice specifically. Once again, it learns the noise profile and then applies that to the audio. Here's an audio recording that was made in a room with an air conditioner running in the background. The sound of the air conditioner isn't too overpowering, but we're going to see if we can get rid of it anyway with the voice denoise module. Here's an audio recording that was made in a room with an air conditioner running in the background. The sound of the air conditioner isn't too overpowering, but we're going to see if we can get rid of it anyway with the voice denoise module. There are switches to allow for further optimizing the algorithm for spoken word or music. Two different filtering options offer a choice between surgical, which may provide better separation of voice and background noise, and gentle, which promises fewer artifacts. So the spectral and voice denoise modules utilize spectral processing in the background to remove unwanted sound.